So good evening, everyone. Thank you, Bhavanam CTC, for giving me an opportunity to talk about this topic. Yeah, so I'm really sorry for like the 1 week before I couldn't do this webinar because I was diagnosed dengue positive, so I was very sick. So today, as I was a little bit okay to do this. Yeah, so the topic I would like to take is the introduction to BIM, transforming the future of buildings. So these are the points I would like to mention. So I like to consider this not as a webinar. I'm a professional working as a BIM engineer in Latinum company, Hyderabad. So I would like to do this as a just to talk to you about the opinions and the things I understood from the experience I worked in a BIM career to share to you. That's the thing I would like to do. Not as a webinar, like talking about some topic, like without stopping, talking continuously. I don't like that. It's better to, I would like to share the opinions and things I understood about BIM, what the people like entering in the BIM career should know before starting the job. That's what I would like to do. Okay. Yeah. Before starting, let me introduce about myself, a little bit introduction. I'm a BTech Civil Engineering graduate in the year 2021 and I'm 2022 qualified. Previously, I worked as a junior BIM engineer in the BIM Engineers company. I hope everyone know. Like they have two branches in Gurugram and also new office in Chennai. Currently, I'm working as a junior BIM engineer in Latinum Private Limited Company. It's in Hyderabad. So it's a subsidiary of Shobha Realty, Dubai. Yeah, currently I'm just started my working there. It's almost only 1 month. I'm working as a junior BIM engineer in architectural display. Okay. So before starting, I would like to know this quote. I heard about this go through Google, some social media. Yeah, I like to explain the meaning of this one. Maybe feels simple, but it's very important. We develop a passion for learning. If you do, you will never cease to grow. So as in BIM, it's never been starting a BIM model is not a growth. It's just a starting. If you need to grow, you have to develop a passion of learning. Learning everything that you will never know. You have to learn every hard steps, every hard things. You may feel very exhausted in the starting, but still you force yourself to learn. Then only you can grow. That's the main thing for every career, not only in BIM, every career you need to do this. So I will move to another like page where I explain the career levels in BIM from by starting as a junior BIM engineer or a modeler to which level you can grow. So to grow all these steps, it's like a taking steps, higher steps. To take all these steps, you have to learn everything. There may be people to help you, but there may not be people at every time. So you need to learn yourself. So that's the main reason I mentioned this quote. You have to develop a passion for learning. Learning doesn't mean like the when you still know, even if you learn that you didn't get nothing, but still you learn. That's the main thing you have to understand. Like if you learn, you get money, then you mean, oh, it's good. But if you learn, like I don't get anything, but still I choose to learn. That's where like the growth comes. Okay, that's what I learned. It may feel simple, but in like upcoming careers, you will feel that. Before, without wasting time, I will start. So first, hearing the word, I think everyone will should know this definition, or like everyone studying in this Bhavanam CTC, the BIM course must know the definition of BIM. What is actually BIM? So BIM is like building information modeling. As the term itself, it explains. It's like the information of every building we model is in the BIM. Okay. It's not only just a model, it's an information of the building. So it's actually a process involving the generation and management of digital representation of the physical and functional characteristics of buildings and other physical assets. It's like, so it's not only like a process, it's a representation. That's what makes the BIM unique. It's a digital representation. That's what we do the BIM only in softwares. So we do the digital representation of what? A building. Not only digital representation, what it contains, the physical and functional characteristics of the building. So what is the difference between physical and functional? The physical characteristics of building includes the physical things we can see of that building. So if you are constructing like any four-story building, a hospital or something, we can see the like the stone, the building components we are using to build the building. We can see those are the physical properties. Which stone we using, which material we use for particular door or everything, every floor material which using can be seen. Those are represented by physical characteristics. So what is functional? Functional characteristics means the properties of a building we cannot see. We can only describe. It's like if you take a floor, if you take a floor of the first level of the hospital building. So what is a material? What is a material used for that particular floor? What is the thickness? The thickness inside that floor we cannot see. So every properties that is like kept inside the building, like from which company we purchase that floor, like which company material we use for the painting the wall. So every details we cannot just like written on the floor, like written on the wall of the building. We cannot do that. We can only enter the data as a functional data inside the BIM model. Okay, so every functional data that we cannot see, but we can only explain. And the physical properties we can see, both are encrypted inside the model we created using the BIM softwares. So actually BIM is not a software, it's a process of doing all these. We actually create a model, and the model contains the physical and functional data of the building or anything we do. This can be building or a physical asset also. It can be infrastructure. Building means a building, so infrastructure means everything we use for transportation. It's like highways, railway, everything is under infrastructure. For both also we use this BIM process. Okay, so the every data we can store inside the model and use for many other purposes. Those purposes will be discussed later on the next coming slides. That's explained in the BIM. Okay, so BIM is different from CAD. CAD is actually a drafting. That's what makes BIM different. So in the previous times, people use CAD only for construction. It takes so much time during the construction. Like there is no collaboration. Like it takes so much time. I actually only, as you know, 21 I passed out. I didn't ever use this CAD. Currently I'm using the BIM only. Like, so I never worked with the CAD. I only heard about the disadvantage of being used in the CAD. So I can only explain the disadvantages I heard from other one. I never used it. So that's why I'm saying. So it's like the BIM, using the BIM, we can make the construction little bit more faster. Not little bit, it's about more faster compared to CAD. So it's make the errors happening in the construction can be reduced. That's the main thing we have to do. Okay. Not only errors, the wastage of material. As we know, in many construction site, with the contractors like purchase so much material based on the estimate. And after that, it may not be whole required. Many items will be wasted during construction. Maybe the wastage can be also said as after construction, there may be errors. So they have to break it again and build again. So the break materials cannot be used again. So that's what we meant, like the wastage. So using BIM, we get a correct, accurate estimation of what material is accurately needed. About 0.00 accuracy we will get, but about how much quantity of material is required. Every material we use in the construction can be accurately estimated, accurately scheduled using this BIM, so that no wastage of material occurs. All these points I am saying, I am not added in the slide because there is so much point to add. So it will be like a group of 100 pages of slide with points. So I think it's better to explain so that everyone just listen. And if you got any point, just write it down. It's better. So other than a points, like a slides, lot of points. That's I don't prefer. That's why I'm just saying. So that if you like listen carefully and write the points you understood. Okay. So it's like Yeah, I think someone marked here. Yeah, it's like the people inside this BIM process, the people who are the people we say the stakeholders. We use the term the stakeholders. The stakeholders means the people which are involved inside the BIM whole process. So the from the left side, right side we start. The owner is also called the client. So in every project we call the owner as a client. Okay, he's the main thing. For him, we work his ideas to make his work, digital ideas as a real life one, we do work. For the client, we work, okay? For him, to the site, the person who work is called a general contractor, okay? General contractor make the purchases and do the construction in the site. The structural engineer, as we all know, do the structural parts, the design, everything he do, together with the architect. The architect and the structural engineer is entirely different. I hope everyone know. The architect do the architectural parts only, but the stability and other things has to be controlled in coordination with the structural and architect. The mechanical engineering and electrical plumbing people all do the MEP works, like the everything other than the structure, everything for the electricity and the drainage, everything to the mechanical people. And the BIM manager. BIM manager is the main head of the BIM department. So I will come to that. There is another plenty of people below the BIM manager. So from the BIM aspect, BIM manager is the main people, main people like a man or a woman in can be. It's a main person who control the BIM process. So they report to the owner and client. So every detail reports to the design, everything they can contact the structural engineer. Like from this diagram, you will understand that there will be a group easy communication between the every 6 person in this photo. So it's never like the BIM manager has to contact mechanical engineer. So the BIM manager contact the owner, and the owner contact someone. Then like he give the contact number of mechanical. That is not how it works. Everyone contact very easily in between them. Okay, the communication between every person is very easy here. So the next one is like the one I like told the first time. It's a career path of a BIM. If you get into a BIM job, these things you have to get first understood. So it's like only you can start the BIM job as a BIM modeler or BIM engineer or BIM architect. Normally, companies select you as a junior BIM engineer or a junior BIM modeler or junior BIM architect. So if I think like some of you might know the difference between modeler engineer, then I will say it's like the modeler is a person who does only the modeling job. So we have to do the 3D model of the building. So we have a plan from the contractor, we have a plan, CAD file. From that, we do the model. Those job are done only by the junior BIM modeler or BIM modeler. But the BIM engineer is a person, other than modeling, there are plenty of details we have to add in the BIM. Okay. Like there is facility management data. Facility management is like the information required for the building after the construction. So every data in that building is required for the facility managers for managing the facility, and every schedule and every quantity, every sheet work, everything other than modeling are also done by the BIM engineer. So then the design stage of the building. So in the design stage of the building also we have to like do the BIM part. So that stage also controlled by the BIM engineer. So other than this, is the main thing you have to know. Other than modeling, what are the other things we have to do in the BIM process? Those are done by the BIM engineer. If only modeling is done, then you are a BIM modeler. Okay. But in normally, from my experience, every people hire you as a BIM engineer or BIM modeler according to the client's requirement. They just choose one name. In my company, I do the modeling and sheet work also done, but they create me as a BIM engineer. In my previous company, there is only modeling, but also they called me as a BIM engineer. So that doesn't actually work according to theory. So the next one is after working for 1 or 2 or 3 years, you can become a BIM coordinator. BIM coordinator is like there is 4 disciplines. So I will come on to that. So I just saying on the discipline only. I will come on the next, come about it next slide. So there is different discipline in the BIM. Okay. So for the different discipline, we have a different BIM, like a architectural BIM engineer, structural BIM engineer, MEP BIM engineer, HVAC. So different one. So every BIM engineer in that particular project has to report one BIM coordinator. So the BIM coordinator controls all the disciplines. Okay. Now after working as a BIM coordinator, you can become a team lead or a BIM lead. So it's a more higher authority. So now after that, becoming to BIM manager. So BIM manager, I think you have seen the previous slide. BIM manager is like the main person in the BIM for a whole project. So now after that, you can become the head of the department. So he's like similar to BIM manager only. So BIM manager, to become a BIM manager, you must have almost 10 years of experience. Almost. So there may be people working more than 5 years as a BIM engineer and becoming a BIM coordinator or something. There is a different other kind of people working for only 1 year as a BIM engineer, then become BIM coordinator. That's all depends on how you work. That's the main thing I mentioned the first quote. Like if you have a passion to learn, you will never cease to grow. It's like a person who works hard to learn can easily become a BIM coordinator even after 1 year. 1 year is enough. Then you can work as a BIM lead. It's all depends upon how you work. So if a lazy person who works slowly, he don't need to grow. Is the salary enough? Salary who is getting for a BIM engineer is enough. Then he can slowly become a BIM coordinator after 3 more 5 years. Then it's okay. But if you're planning to stick on the BIM career, you must plan from the starting itself. Okay, at which age, what year of experience I have to become BIM coordinator. To become BIM coordinator, what should things I should study? So you should plan your career accordingly and manage your time. So I am currently only a BIM engineer. I am just planning to become a BIM coordinator in the next 2 or 3 years. So still working on that. I'm only like almost one plus year experience I have now. Okay, so we are coming to our topics. So yeah, these are the topics I would like to mention now. To precisely speaking, these all topics are not entirely different topics. Okay, the first three I could mention as a different one, and the next from the interoperability and open beam to digital handover, all these are actually a single topic. It's a storytelling. These are different topics we use in the different stages of BIM process. So that's why I would like to stay during the starting. So it will not be like explaining like in a chapter we will see the index. So chapter 1, chapter 2, chapter 3. It's not like that. I'm not explaining the chapter 1 as a different chapter 2. It's not like that. In BIM, all these points are the different points which explain the different parts. That's only. Yeah. So let's start with the first one, BIM components. Okay, sorry. Before that, this one, the disciplines. Yeah, I hope everyone know these are the 4 disciplines: the structure and the architecture. This is the MEP and HVAC. Structure is, as you know, the beam, column, slab, foundation, everything are controlled by the structural BIM department. And the architecture is like what the inside of a single entity, single space has to be controlled. Like if there is a, what to say, 10 meters square of area in a room. So how we control that? They say it's a office room. And the architect, the client told them to the architect that there's a 10 meters square of area and I want to make this as an office room. So how they make them as an office room. So how we control where the window will come, where the table, which carpet, where the ceiling has to come, like everything, how the room has to look like according to the client's requirement is controlled by the architect. Okay, the structure done by the structure one. And the MEP. Normally, the MEP BIM discipline is mainly come in a large projects like hospital or any like a shopping complex, something. For a normal residential, we don't actually. I hope you know everyone that like in residential project, we don't use like this much ventilation and everything, very duct, we don't use. So normally for the like big multi-million projects only, we use this MEP. Those are required. That's what ventilation and everything we need separate duct. And for firefighting also we need to separate something pipe and everything. So for the those type of projects only we require the MEP BIM department. So the next one is HVAC. It's like heat, ventilation, and air circulation. Okay, the circulation and ventilation things are controlled by these people. So these are the main disciplines in the BIM. So all these disciplines are controlled by the BIM coordinator. So there is different BIM manager and different BIM engineer and BIM modeler for each of these disciplines. Okay, come to the next first chapter. It's like BIM components. So as this name says, BIM components is the component we used for making the building. Hello?
Hello.
Yeah.
Ma'am, I late joining. Hello.
Oh, it's okay. It's okay. Join us.
Please preview.
Sorry. We just started
Please.
on.
Okay.
Yeah, we just started to getting only previously I just gave an introduction only.
Okay. Thank you.
Okay. Yeah, so BIM components. So first we got to the definition. BIM objects. It's only also called as a BIM object. So digital counterparts of physical products used in architectural, engineering, and construction. That means AEC industry. So they store data and geometry. If any element changes, the model updates that change. So that means, so as we say in normal construction, I think like everyone is better civil engineering. So everyone must see some of the construction site in the real life. So for that, what we use like the bricks and stones, like tiles, everything. There is a physical product they use to construct the building. But in BIM, how we do that? We only have a digital representation only. So we need digital components. So it's like a game. I hope everyone know the Lego game. So they use the like a what to say, a counterparts, just a 3D representing a digital element. So those digital elements, single one, it can be representing a wall. Yes, like it can be represent a stone, it can represent a door, a window, everything. Every component we need to model that particular building is said as a BIM component. So in this image, I hope like you could understand very easily that everything we need for their building is represented here. It can be anything. Can be anything means from very small zero to nail, a wall nail to a big like a floor or a roof, everything can be a BIM component. So from this image, there's different plenty of things. Okay, so this one is a chair. Okay, this one is a chair here. And this one is a pipe. This one is a type of door. This one is a wall here. So everything, okay, it can be used in the BIM process to model, and also not only model, they store data and geometry. Geometry also we can control. So if there is a wall, it can be controlled like how much length and width and thickness it has to be, and also to store the data. The data that we mentioned the starting of the BIM like definition. I hope everyone remembers. It's a not only physical data, it's a functional data also. So the what function? So what functional data? That may be the question arises. So the functional data depends on the like that physical product we use. So for a door, if there is a door, if we consider door as a physical product, for the door, the functional characteristics like include can be said as a which material is used for making the door. Okay, the wall, like the handle used in the door, from which company they made. So how much degree we have to bend the door to open. So what is the hole size for that particular handle. So everything that those are the functional properties. The physical properties like the thickness of door and the door height. Normally it is 2100 mm. So those are the properties. So it depends upon the material. So the functional characteristics depends upon the function of that particular element we used in that BIM process. So normally while working as a job, we will not say it's a BIM component or BIM object something. For interview only, they ask you like what is a BIM component, BIM object, everything. But normally while working, we call everything as a family. It's the term we use, family. So instead, in Revit, we say wall family, door family, window family, floor family, roof family. In wall family also, we create different types of walls. Stone wall, it can be wood wall, it can, okay. Even though taking as a stone wall, the thickness of stone wall, like 230 mm wall, 400 mm wall, everything changes. So everything in general, we take it as a family, okay. So these are the group of families. There are many families. There is many more topics that we have to discuss about this. So it's not all only on not possible because like this is a very large topic. So as it is an only introduction webinar, I'm just sad I have to limit this one. So about topic to talk about this family, there is a lot of information I have to share. So I just brief about them because there is only 1 hour available for me to discuss. So the family is like a system family is there, like a laudable family is there. It's like while using, if there is even people who already use software, they know there is already a system family. It's like the Revit the people, like the Autodesk company who founded the Revit software has already loaded some family components. Those are called system family. So we can also create a new family if there is a new type of material or component required in a building. Those can be created from outside or from the software also we can create and load into the project. Those are called loadable family. So a lot of topics is there. So I just want to let you know that those are BIM components are called as a family. So the next one is like the level of detail and LOD and the levels. Yeah, these are the next two topics, LODs and levels. LODs and levels are the two type of classification used to classify the whole BIM project. So first of all, let's discuss about the level of detail. So LOD is like, it describes the it's like classifies the BIM based on the accuracy we are delivering. So it's basically start from LOD 100 to LOD 400. Actually, there is exist LOD 600 and 700 also, but normally we have to discuss only up to LOD 500. So LOD 100 is like a pre-design stage. So it describes, so after explaining this 100 to 500, I will again explain what is LOD, so you will better know more. So LOD 100 is like a pre-design. So pre-design means before construction, we do create an LOD 100 model. So that model represent what the actual client required. So before the construction, the client talk with architects. So they say, I want what to say? I want a sunflower looking like a building. It has to be petals. So the center of my building has to be in the center as it look like sunflower. So the rooms has to be in the similar to the petals of the sunflower. So that is a concept he has. That concept has to made into reality. Those are done by the structurals and architects. So the just basic idea they made by that client is made into reality using this LOD 100 model. So it's just an approximate data. Just an approximate means just represented by a building blocks. It cannot be like the correct shape of the sunflower cannot be made. It's just a, what to say, from the clay. We have a handful of clay. From that clay, we make the sunflower shape. Then how it look like? That is what LOD 100 is. Just to represent the client's idea, we use the up to LOD 100. If they say, I want only LOD 100, then it's just a shape representing what the client required. So from looking at that design, we will not understand anything. But just we understand that, okay, he just required a sunflower-like building. So next one is LOD 200. LOD 200 is more like the dimension of the like building is marked there, only the dimension. So if we say, let's take an example of like if we want a room inside the building of 3 meter, 4 meter, or like 3 point, accurately say if it is 3.1, 4.1, then we will create a room of 3 into 4. So it's an approximate 3 into 4 like dimension room he required. So that's represented in LOD 200. It's a schematic design only. So every day, every BIM model we created up to LOD 100 and 200 is all approximate only. It cannot be used for any construction or anything. They only represented, like used to represent the client's idea only. Okay, that's the main thing you have to get to know. So the next one is main important LOD 300. LOD 300 is mainly told as a design development. The important turning stage of the building construction came in the LOD 300. So if any client approaches you and tell you that I want a LOD 300 model of my building, then it means we have to design the building. We have to design the whole building. So if everyone know the sunflower type building is not possible, it may be possible in the future. Okay.
Hello.
Hello,
Hello.
Agash. Okay, thing is mistake. Okay. Yeah, LOD 300 is like if anyone tell you to design, like to make an LOD 300, it's like design the building. You have to design what beams, what beam thickness, what reinforcement you have to make, everything you have to do. So next one is like LOD 350. LOD 350 is the next stage of design. After designing, you have to what you have to do? You have to do the construction stages. The construction stage is like before construction, you have to you have to call a contractor. The contractor is the person who construct the building. Till LOD 300, there is only we have the design data. The design data means what we designed, only we have. The only paper we have. But we don't know what material and everything, what items are required to actually construct the building into site. Those stages are to be done only by the contractor. So the contractor came in the stage of LOD 350. It's like a construction documentation. So after the construction documentation only, we can start the stages of constructing the building. So the next one is construction stage is LOD 400. If anyone say you that I am in the LOD 400 of the BIM stage, so it means it's already started constructing. Not started, it's like about to start. If anyone says I have just about to complete LOD 400 means the construction has started. So if anyone says I am just only starting the LO, I am just starting to get LOD 400 after the 350, I am just starting. It means they are on the stage of like constructing the building. They have got every information required to construct the building. Hello, is there anyone like anyone have doubt or anything?
No, sir, you may continue.
Okay. So it's like the main, I'm just explaining all this one with the main points we need to know. That's LOD 400 means construction stage. The building is actually in construction. So LOD 500, that's the main twist. LOD 500 is the main like in the final ending, we can say in a final ending point or something. LOD 500 is as built. So from the English word as built, thus we can like understand what actually it is as built. It is the model we do actually according to what it is built. So after the LOD 400, the building construction has started. So after like it's maybe 2 year, 1 year or 2 years according to the time duration, they have completed the construction. And during the construction, there might be some changes according to what the designer made and actual the contractor has done. So if there is a beam here and also a column connecting the beam, after constructing the contractor say, we don't need this column here. We have to change it to 2 meter backwards. So after constructing from the design stage, from the design, they have a CAD file. So they change the CAD file. So, okay. So they change the construction from the input. So change the column. So after constructing, there is no, if there is a beam here and a column here in the actual CAD file, after constructing, the contractor is told not to build that column. So if the site, like the site engineer who has designed the building or the structural engineer designed the building came to the site, came to the building and saw that like there is no column here. So and then he will argue with the contractor. I have given you a column here. Then why didn't you construct it? So it may be according to the any site condition or anything, it may be different, but the input they have given and the output is different, right? So at that condition, in this type of condition, in this type of issues that the model we do is like the LOD 500. So LOD 500 is like, we design, like we model a BIM model, like do the model in a way, which is actually exactly looks like what it is built, not what it is modeled, like not it is, sorry, I'm also confused. Not what it is designed. It looks like what it is built. There's only like less than 5% chance the issues will happen as I told. They cannot change the column like according to the contractor, but I'm just saying an example only. If that is happening, then it is LOD 500. For example, I will say while working in the previous company, I worked with the NEOM project. I hope everyone know. For the NEOM, like there's a hospital, NEOM Advanced Health Center in Saudi. So there is like in the hospital, there is it's like in the interior portion, there is an opening. So there is like a handrail around that opening. Okay. The handrail is like everyone entering the building can see still the downstairs also. So there is a handrail design already there. It's in the LOD 400 stage. So I worked in the LOD 500 stage. So while working in that, they have changed the handrail design. They told, the client told, I don't want this design according to the design, according to the LOD 300 or 400. I want another type of design. So we changed that and did another design. So after building, in the as-built model, that handrail design is different. But as we see in the LOD 400, it's actually different. So in this type of condition, we use the LOD 500. If there is no difference between LOD 400 and 500, we consider the LOD 400 as the same as LOD 500 also. Okay, I hope everyone understood. I'm sorry if there is any confusion. I will just briefly once again. LOD 500 means just to represent the idea of client. LOD 200 is we have a dimension of the building, like what size it is, like what is the height of the building. Everything will be marked, but not accurate. So also everything will be approximate. Everyone, if anyone comes to you with an LOD 200, it's only approximate. The main word you have to understand is it's approximate. LOD 200. LOD 300 is design stage. Every design here for the building is done using the done in the LOD 300. So LOD 350 is the contractor stage. The contractor comes and the selection of contractor for the construction is done on the LOD 350. 400 is like construction stage. For the level, so what is LOD? Level of detail. So the level of detail in the LOD 400 is like using the input you have given through the LOD 400, you can consider building. So if you given a normal person with a basic knowledge of civil engineering, you given him an LOD 400, then he must know to construct the whole building using the LOD. That much detail has to be in the LOD 400. So that's I can say in simply. So any person just seeing the LOD 400 can how to construct the building, has to know every detail that need to know to construct the building. So that much detail should in the LOD 400. So LOD 500 is like after considering the building, what the building actually looks like. So what are the changes are made can be reflected in the LOD 500. Okay. This is the main, like one of the main important topics. Every company interview, they will ask the LOD with every detail they ask. Okay. So you have to like study a lot about this topic. So you may just note about this one LOD. This is the main topic every company asks in the interview. Like you will get confused a lot. You have to study about this one. So they will ask a lot like confused question about this one. So you need to know, understand. So I will just use the next slide to like explain more. Yeah. So the first image represent the development of a whole building according to LOD. So as we mentioned, LOD 100 is just a representation. It's a rectangle look like. So LOD 200 is like, okay, not a rectangle. It's a home. So it's a house. So it's need a like an inclined roof. It's something required. So LOD 300 is like that same LOD, like inclined looking residential building has some window walls and everything. So we designed that. So LOD 400 is like the construction. So as you see the LOD 300 and 400, you can see the difference between the construction happened. Like there is a handrail, there is you can see the site, which floor used, which roof material used, everything is in the LOD 400. So LOD 500 is different. So in the LOD 400, you can see a different kind of paint material. In LOD 500, it's different. So after constructing, whatever the changes made can be reflected in the LOD 500. So this LOD cannot be used not only for the whole building, it can be used for every BIM family. It's a BIM object. For every BIM object also, we can use the LOD. So coming to a door, we can say LOD 100 is a concept phase. So it's a concept. It has to be an opening, a rectangle like. So it's a concept. LOD 200 is like conceptual. Sorry, it was a grammar mistake. I'm sorry, spelling mistake. It has to be schematic design, not conceptual. LOD 200 is schematic. It says it's a door, but door still approximate. LOD 300 and 350, it's a tender. Tender stage means the stage where contractor comes. So it's like design. We accurately design the material. So LOD 400 is like for constructing what data are required. That is mentioned in the LOD 400. So next is LOD 500. After constructing, what it looks like. It's as built. I hope you understood. So as the LOD 300 and 350s are important, I am again explaining about those topics. Sorry. Yeah. LOD 300 is like accurate modeling because it's a design stage. Detailed shop drawings. Shop drawings are drawings we use for the construction. Like we given to the contractor for the construction. Elements are defined with specific assemblies. Detailed 3D modeling of building components. Precise quantity, size, shape, location, and orientation of the building is mentioned. Okay. Precise quantity means how much quantity. Taking an example of a door, how much doors. The same quantity of door is required in a single building. The size, shape, and location and orientation means is it opening inwards or opening backwards, everything. Coordination between different trades are happening. The trades like discipline, the architectural, structural, and MEP. BIM coordination and clash detection. So about this clash detection, I will like explain the upcoming slides. I will explain. So whole the like from the scratch, from the very much accurate detailing we will do in the LOD 300. That's you must know. So next one is construction documentation is LOD 350. It represents how building elements interface with the various building system, which means the difference between LOD 300 and 350. It's like what we say. We explain about a door in LOD 300. We explain about a wall in LOD 300. Okay. We are actually placing that door in that wall. So how that door is connecting in that particular 230 mm wall, that we are explaining in the LOD 350 only. Because like the door cannot be just normally placed in the wall. We have to place the lintel above the door. And there's a frame connecting and how the stone is connecting, how the mortar is placed in between the door frame and the wall, that every detail, how that one building component interacts with another building component is explained in the LOD 350. That's the main important difference. I hope you understood. If anything you can imagine can be explained in the using 350. It's like one building component interacts with another building component. It's not explained in the LOD 300. Only a single component is the level of detail of a single component is explained in LOD 300. But the interaction between, like how the connection between one component and another component is explained in 350. Okay. And each component with the what materials and products are used are also explained in LOD 350. So generate construction documents. The construction documents means every construction documents we required for building, for constructing that building. So it's like normally the construction documents required for a construction is like what we say. There is a general note page, general note sheet. it includes what are the dimensions and everything we have to follow. Like, I don't know if everyone would know about that. Like, it's a list of sheets required for the contractor to construct the building. It may not be just a 2D plan of like a first level, second level, third level. It cannot be there. It includes all the data. It can be a schedule. It can be a like typical drawing. It can be a foundation, every detail. So those all construction documents has generated in the LOD 350 stage. So comprehensive cost estimation and quantity takeoff. So it means the quantity and the cost actually required for the whole building construction can be estimated during this stage. Okay. So there is a main advantage of BIM in which we can reduce the construction errors. Okay. If we estimate the total construction cost of the building as a like what to say 50 lakh, then it's accurate. If from the bill model we get it as 50 lakh, then it is accurate. No single penny is wasted. That's the main important thing. It's the main advantage. And quantity takeoff, like how much quantities. So from the quantity takeoff itself, we get the cost. Okay. If we get the like for like the first floor slab, if the from the BIM model we get the quantity as a quantity of concrete as a 100 m cube. Okay. So from that rate of concrete per m cube, we can calculate the quantity of 100 m cube, right? So that's how we do from the BIM model. We do a schedule. There is a schedule option in Revit. I hope everyone would study that. There is a schedule option in Revit. From the schedule option, we can take the quantity of the every construction material, and from that we can add a cost row also. So from the we multiply that from the schedule table, we have that, what to say, we have the quantity. We multiply the quantity with the unit rate. Okay, similar to the, for a 1 m cube, if they say it is 150 rupees, then we have 100 m cube. So how much? 150 into 100. So that much amount is required. Every accurate detail is we get from the LOD 350. Okay. So this much about the LODs. If we explain more, then we cannot complete it by 1 hour, I think. Okay. So the next is like, oh shit, sorry. As I'm really sick, I'm not in a to start the video. I'm really looking bad. Okay. The next is level. So level is like, there are actually 4 level exist. L0, L1, L2, L3. L4 is like some more advanced. We don't need to discuss about that. So so the LOD is like the accuracy of detail we represent. So, but level is like the level of collaboration we do in the BIM process. Normally, to do the to get all the advantages, we have to follow the level 3 BIM level 3 BIM. It means full integration. Level 3 BIM means the 4th level. Actually, starting from 0, so the level 3 is 4th one. Level 0 is like the first one. It's like there is no collaboration. Separate people, like the separate stakeholders in the project, do their own models, CAD files using prints and paper only. So they do their model differently and they communicate with the person they required only. So the next one is like partial collaboration. Everyone create their own model, but they share their data to a common data environment. I will discuss about the common data environment in next upcoming slide. So they create their own files, their own data and everything, and they share if required to a common, like a common, what to say, a common type of platform. A platform we drop the data and everyone coming to a common data environment can get the data. So, okay, I will explain in detail about that one. Then you will get to know more. So you just know that the level 1 is like, we just create their own data, but share the data as a common data environment. That's only. But there is still no collaboration between the different people. So level 2 is like the third stage of BIM collaboration. It's like we get full collaboration, which means different people on the BIM process create their own data. sorry, their own file they use. For architect, they use their own file. Structural engineer, they use their own file. Client have their own file. The BIM manager have their own file. Different something, but they will convert every of their data files into a single common format. It's like common IFC, like industrial foundation class. IFC is called industrial foundation class. It's a common format which can like help everyone in the BIM process can easily access the single format. So it's like what we say. We know for a PDF, okay, before creating a PDF, it can be a Word, it can be a TXT format, and there is plenty of other TXT similar format for a file, a type file. So everyone for it is easy to handle like in a TXT format is a PDF file. Okay, we can easily convert it to a PDF using many website. From the PDF, we can easily share the file. So even if a person open the PDF file, no changes will be happen to that particular text because no one can edit. Only a text file can edit. So they convert the different format into a PDF file and we share. The similar is happening in the BIM level 2. They have the architects, structural engineers, clients, and BIM managers have different files with a different format, but they cannot share their data because if anyone happens, like any changes or any errors that happen to the file, their all data will be lost. So what they do? They just convert it into a IFC format. It's a like .ifc. What it looks like. So from that file, we can share the data very securely so that it will not nothing error will happen to that particular file. But still, there is no like it cannot say full collaboration. Why? Because they create their own separate files and only just converting them. Okay. And so also clash detection is done. About the clash detection also, I will explain the next slide. So the yellow things I have highlighted, I will discuss on the next coming slide. That's why I just given them. So the clash detection and common file format is done in the BIM level 2. So just briefly about the clash detection. Clash detection is like identifying conflicts between the elements or identifying conflicts between the families. Okay, if there is a wall coming in from 0 to 90 degree, like a normal wall passing north to south. Okay, and there is another like wall from west to east passing. If both like conflicts together, there is an error. Okay, that we consider as a clash. If there is a door in the particular wall, okay, if the door has to be just touched to the wall, if it touches another window or something, then it's also a clash. Okay, I understood, like everyone to understand. I will explain it in detail with the pictures in the next upcoming slide. So I just want to let you know what it is. So that's what clash detection is done in the BIM level 2. BIM level 3 is like full integration. So that's the main important stage of BIM. Like everyone has to do in the BIM level 3, then only we will get the full advantages of BIM. So it's like every stakeholders in the project making a single file. And from the single central file, they create separate local file to work on that and share and save updates accordingly to the single central file. And that single central file is converting to a single IFC file. In the previous one, what we say, they create separate file are converting to IFC and shared. But here it is, say, first of all, before starting, we say, save it as a single one file. And that one file is converting to a IFC file. So this is a full integration. So every discipline collaborates through the same shared projects on a single central model. This is the main important word here. You will know like while working the central model. What is central model? What is a local file? Everyone will ask. You have to study this. All stakeholders can access the single file shared using OpenBIM. This OpenBIM also I will discuss. Okay. So central model and local file is like central model is the one single file created by whole person. Okay, one of the BIM manager will create the central file and different person working like the BIM coordinator, like the BIM BIM engineer, BIM modeler, everything will create a separate local file from the central file. So it's like, let's consider it as a sunflower, okay? The central yellow portion is the central model. And every person working can create a separate local file. So separate local file is like the different petals. So they create separate local file as each petals. So each person working on the different petals. So after completing their work, they save the work, and they give synchronize option. There is a synchronize option in the Revit. From the synchronize option, we will get all the saves or the work done by different person into the yellow portion again. Yellow portion means the central model. So that central model is saved. So the owner can access the central model as an IFC. The central model is converted into IFC. Okay. So he can, without making any changes, he can see that central model and to what work the every people has done, everything that we can understand. Yeah, okay. So the next one is like, what to say? The first yellow mentioned one, common data environment, CDE. So from the image, I think everyone could understand the first image. From the left, it is saying these are the different person including in the project. The client, the manager, engineer, supplier, project manager, facilities manager, subcontractor, main contractor. So there may be a stage of construction, like some person has to interact with other person. The main contractor has a lack of reinforcement, like a steel bar he has missing. So he has to contract the, sorry. Yeah, he has to contact the supplier. Then the supplier may have to contact the engineer. Sometimes the engineer has to contact subcontractor. The facility manager may have to contact manager. So every communication in between them is only single phase. So they has to contact one, the other has to contact them. So it will create a clash. So the communication between them is not proper. So it will cause a mess. Okay. Like the client will say something to a project manager. The project manager understand only 80% of that. Project manager explain that 80% to the manager. The manager can understand only 70% of that. The manager then explain that to the main contractor. Then he also understand the less. So the clarity of the information shared and get to the final one. The person who actually work is us, the BIM engineer or BIM modeler. So as the client gives 100%, project manager gets only 80%. But actually from the higher authority, the lower people, the actual people who has to work, get the information, the idea of information is only 10 or 20%. Then we will work according to the 20%, but we believe that the 20% is the correct one. So after working only, we will know we have done the wrong one. So it's a complete mess happen only because of miscommunication between the different project stakeholders. So this is the traditional information sharing. So after coming with the common data environment, there is one CDE. It's like, as we say, the similar concept of a central file and a local file. Let's take an example of a sunflower again. The CD is a central petal. Okay, every person working on the every person working on the project report or what to say, share the information to the CD. The CD can be set as a YouTube or like any social media. Every social media is a digital platform, right? Similar to that, only the CD is a platform for sharing the information. So for CDs, there is an account for every person who can log in. And the engineer can log in and add his data inside them. The client can log in and can see what stage of the construction stages it is. So how much quantities of reinforcement is has bought, how much has used. Supplier will add the data about how much he has purchased, how much has again he has to do. The subcontractor adds the subcontractor adds the data about like updates in the construction site, everything. So everything according to what their role, jobs and responsibilities, they will add the data in the CD. So the communication in between them is very easy. That's the main use of CD. Okay. I hope the first one is clear to everyone. Common data environment. The common data environment is also one of the topic of our webinar. So next one is like IFC. Okay, before IFC, I'll explain the clash detection. Yeah. Sorry guys, like in our Indian construction, every construction is very accurate. That way I didn't get any image of any wrong construction. Those wrong construction only I can add as an image of an example. I get only this one, the Shutterstock image. So it's like this existing stair. Okay. But it's a other side of the image. So the real like stair is on the other side of the wall. So a little bit of that stair has penetrated through the wall. So it's a clash. Okay, actually the side of the stair has touched the side of the wall, but it actually penetrated. So it's a clash. This type of things are considered as a clash. Okay. Yeah, like we don't intentionally the people won't do this type of mistake in construction site. Okay, we will know if while working, but while modeling like a 100 floor type of building we are modeling, we will never know like what mistake we done. Okay, we like unintentionally we have like modeled this type of stair, like while moving a wall or something, maybe the stair has touched it and the stair has penetrated, and after some submitting or something only we will know we have made an error. So that's why we use the clash detection clearance tool. Okay. Using that tool, we will, after completing all the modeling, using this tool, we will get to know like what type of components, what type of families in the building has penetrated and clash. The clash means the conflict between two elements. So that's a main important tool in Revit. So the main Revit, using Revit also we can use the clash detection, but it's actually up to limit. So mainly we use this software, Naviswork. It's also an Autodesk software. So the Naviswork is represented by the N symbol and Revit is by the R symbol. There is a link in between them. We do a model using the Autodesk Revit software and we import it to the Naviswork. Then we do the clash detection. So this image and this image, I hope everyone see my mouse. From this image are the stills from the Naviswork. So these are like firefighting pipe. This is a duct. So the firefighting pipe is touching the duct or something. So that's a clash. So it's showing in red color. Okay. Similar here only there is one slab or pipe. I don't understand. Some building component is. It can be a slab or anything. It's actually penetrating to one another. So that's a clash. It will cause a clash in Revit and we cannot submit it to client. It's an error, right? So we correct it. So how do we correct? How do we know there is a correction? That we only understood by from the Naviswork. There is a clash detection tool. That's the main use. Okay, to reduce the error. So from the first definition I told you, like there is a main advantage. We can reduce the errors in construction. So that's what I am talking about here. Like how we reduce the correct error is done using the Naviswork. Yeah, the next one is like open BIM and interoperability. So there is one more topic we have left here, that is common file format. So don't worry guys, I never forgot, but actually I told the every topics in this actually a single topic. It's not a separate. So what I am explaining about open BIM also explains IFC. So this image on the left side explains how we convert a file to an IFC format. So it's like I hope everyone has opened Revit and know how to use it. Okay, anyways, like you know how to open, I think. So there is we save a file from the file option. There is a save option or the save as option. But to convert to an IFC format, we have to use the export option and there is an IFC, this type of symbol. It's save an IFC file. Okay, if we click here, the Revit file. So for Revit, the file format is .rvt. Okay, the .rvt is converted to a .ifc format. If we click here, those IFC format we can share to anyone in the project. Those IFC format we are sharing to whom? We are sharing it to the any person who's required the data and we shared it to the common data environment. Okay, I hope you get it now. We share the data to common data environment. From the common data environment, everyone can access and know at what page of construction they are now. So I'm just using a represent like an example only. Poetic type comparison I am doing. So at what stage of construction they are now can be understood by every person in the construction using this like common data environment platform and that IFC format they are sharing, using which process like an open BIM. Open BIM is like we can share one type of file of data to one person without harming what is the data inside. So it's like I guess everyone has like know about we are framing a photo, right? We have a photo. We bought a 1,000 rupees painted drawing from an artist, but we will never hang the photo like without framing a glass or without getting a cover. We will never hang. Why? Because it will get dust. The artist work will be lost forever if any that like any dust or any sharp object touches it. So what we do? We cover it with a frame. We give a beautiful frame by covering a glass or something. Something we'll do. Okay. Then anything happens if hot water or anything or sharp object touches it, it will never damage, but we can still enjoy the beauty of that work. Okay, that's a simple concept I can say about the open BIM. Open BIM is like every work we have done using the BIM software can be shared as an IFC. But if we share using open BIM, it's like open BIM format we share to other person. The other person can easily access the data inside the work, but cannot change or edit or anything. Okay, that's the main thing we want. We have done spent like months of our time for doing the BIM model. And if you given to some person and then he make a mess out of it, he deletes some windows and something, then he give it back. Then what happens? Nothing we have to do. We have to do the model again. So if we give it as an open BIM format through this process, nothing happened to that single file. Okay, that's the main advantage. I hope everyone get the concept. So it's a collaborative process, allows each and every project member to access the file without disturbing the model. Okay, that's a point I just explained now. So allowing project members to participate in it regardless of the software tools they use. Okay, this is the another thing. So if we model the file BIM model using the Revit, okay. So to open Revit and use any file, we have the format .rvt is required. Okay, we cannot open the rvt file in Naviswork. To open in Naviswork, the file has to be .nwc, .nwd or nwf. To open an image, we want .jpg something format. To open in WPS, we want what? .pdf or something. So for every particular software, they need separate their own format. But if we share using the OpenBIM format, it's a .ifc format. Okay, if we share using the .ifc format, any software we can open that particular file. With using PDF also, we can open that BIM model. With using an image viewer, we can view that file. Okay. The main use of doing this is like the client is a busy person. Okay. He is not a BIM engineer or BIM model or something. He's a businessman. He only invests money. So he don't need extra money to be spent for just viewing the file. So to purchase the Revit, it's like 1 lakh or something rupees, I guess, per month you have to pay. For opening Naviswork, here something other amount has to pay. So if he has to, if we say the person or the company who does the BIM model says like, you have to invest 1 lakh more rupees just to view the file, the BIM model we done, then what will be his opinion? He has spent crores for the building. But we again say we have to spend 1 lakh more rupees. So we cannot say that. He has to just view the file only. So for the view only purpose, we can share him using the open BIM. That's the main purpose. So whatever free software he has within our system, we just share him the file using like from the common data environment for through the mail we will send him. If it is an IFC file, he can easily access with any software inside this his laptop or anything he can access. That's the main advantage. That's a main advantage and main good thing about the open BIM. Okay, it can be sending as a PDF or Word. Like just imagine, guys, like sending a BIM model, like the file as a PDF. With the PDF also, we can just view the building in a with rotating or something. We can entirely view the building. That's the main advantage. Okay. So next is like interoperability. Previously, we talked about sharing the file and like we can access the file in with different software. So it may not work all the time. It all depends upon the accuracy of the model we did. Okay, so everyone working in the BIM model cannot make the whole like accurate model. It depends upon the skill of the person. Okay, that also depends. So that makes the interoperability a main tool. So interoperability is like what to say? If a person has made a BIM model, but it cannot open in another model. If we convert it to IFC and cannot open to another model, then it says the inefficiency of the person. Okay, it's correctly what we say. Because if we made it interoperable, we use the term interoperable, okay? If the model is interoperable 100%, then we can use that particular BIM model to any software. If the model he did is interoperable 80%, then it's like 80% only it's matching to other softwares. There may be errors. If it is less than 80 or 50, 40%, it's like it's only that much accuracy it is. So with the percentage, we say that interoperability value. Every project has to 100% interoperable. The percentage represent, it's like the applications, like the BIM model's capability. So that's the best word I can use. BIM applications capability to share, exchange, gather, and process the same data via common set of exchange formats. So there is a different exchange formats. Those are like the open BIM. So if we share the data, if it is 100%, 100% capable, like to use in another different softwares, then it is 100% interoperable, we say. Okay. So if any person asks you what is interoperability in an interview or something, you have to just to say it says the it says the capability. Okay, there's a main word. Capability of the what? Capability of that BIM model to use in another application to work as an open BIM or something. Okay. Yeah. Yeah, sorry guys, I'm taking a little bit more time. It will complete it shortly. Okay, this page represents a BIM 360. So I just talked about like central file. Hope you remember. The central file is like we create a central file by the BIM manager and we create a separate local file. We can share the central file to other person using two methods. There's a server type method and a cloud method. The server is like the persons and the people working on a different system in an office. Okay, so the different system of them are connected using a wire, WLAN something they connect. But if a person is working in an office in Hyderabad and another person working in Dubai, similar to me in my office, the head office is like Dubai, Shobha Reality, and our office is Latinum Hyderabad. So how we connect that? We do them by the cloud sharing. So for cloud sharing, there is an Autodesk ACC, Autodesk Cloud Sharing for platform. Okay, one of the Autodesk ACC cloud sharing platform is BIM 360. I hope everyone heard about the name. You have to know. BIM 360 is a cloud sharing platform. It's like we create one central model. The central model is attached in the BIM 360. So from the BIM 360, every person in any part of the world can access the central file and create a local file. What about the first one? First one is like a wired connection. It's like every person in a single office, the laptop and the computer connected by a wire. If you have connection with, if your computer has a connection with other computer, the server with the wire, then only you can access the central file. But what about the person in the like Dubai and Shobha? You have to use the cloud sharing platform. So this is the BIM 360 I'm talking about. BIM 360, you can share the central file and every other person in the BIM 360 same account can access the file. So not every person can access. The person who created the central file can give permission to what person you can access. So it's like there's a 10 people in the project. The ninth one created central file and he can choose out of the remaining 9 people how many has to access the BIM 360 central file. He can choose. There's an option. Okay. Okay, the image now you are seeing is the BIM 360 user interface phase. So if you open the BIM, if you open the file, like if this is a project, so something a screenshot taken from the Google, it's not a project done by me. So it's a building. So every data of this particular building can be seen on the right and left side of this. Like the first one is like you can see the different components: door, side, parking, windows, slab beds, stair, railing, structural framing, everything. So everything is like the component, the BIM component. The first one we talked about, the family. Okay. If we select a particular thing here, here they have taken the floor as like they selected this, the floor. So floor, the different physical and functional characteristics representing the floor is given in here. The level, the height of it from the level, room bounding related to mass, structural and everything. Okay. In the left side, we can see which components are selected. In the right side, we can see the physical and functional data added for that particular family. Okay. So this is how a client can see his file. Okay, this is how this mentioned about like framing, glass framing and everything. He cannot delete any component or something. He can just view only. If he want to see the window, like a glass window of the 5th floor, and he can easily access that from here. He can go to the like window. From window, he can select the glass. So he can see the glass window here. From the right side, he can see the level and every data of the window can be seen on the right side. Okay, good to understand. So in the definition, the data exchange platform is a cloud-based method that allows user to share data across apps and teams without the need of importing and exporting. Yeah, this is what I explained in the beginning. It's like the BIM 360 is a cloud sharing platform. So we can share the data. The data we are sharing is what we are seeing now. So IFC format file of the Revit we did in the like RVT format, we converted to IFC format. Okay. Yeah. Yeah. I hope this is the end. This is all like I have to guys discuss about. I will just go back to the starting. Okay, we will just just conclude the BIM components that we discussed. It's starting. It's like the family. What are the components we are using to construct the building? Next is the BIM LODs and levels. BIM LOD and level are the two different types of classification in the whole BIM process. BIM LOD is like level of detail. Level of detail is like represent the accuracy of detail we are representing, and BIM level represent accuracy of collaboration. So what collaboration is required to get 100% BIM output? BIM level 3. Okay. BIM LOD depends upon project. It always varies. Whatever LOD you have to work, it will vary. Next is clash detection. Clash detection is like determining which are the elements of the building are conflicting and correcting it. So there is a more detail about this clash detection. So I will also explain. The clash detection is like I explained you about clash detection using a wall and stair. Hope you remember. Okay, it can also vary. It's like how much penetration the stair has made inside the wall. Okay, it can be 15 centimeter, it can be 1 mm, it can be 0.1 mm, everything. So it also varies on accuracy. So if your client says, if my stair is penetrated inside the wall to a 1 mm, then you just unmind, it's okay. If it is penetrated more than 10 centimeter, it's a big issue. So according to that, you can solve the clash. Okay, I hope you understand the difference. Based on the penetration, we can measure the accuracy. Sorry, we can measure the degree of clash. Okay, there is an option in the Navis. While studying the course, you will study it more. So that's what is clash. So next is collaboration and coordination. Collaboration and coordination is also like another leaf of explaining common data environment. Using the common data environment, there is a good collaboration and coordination between different disciplines. Every discipline in the BIM can easily coordinate in between. I just gave you an image. I hope you remember. Every project stakeholders in the project can easily coordinate. So collaboration is like sharing their information in each other and sharing the communication so easily so that no miscommunication happens. So next is interoperability and open BIM. So they are also similar to what we have discussed in the last slide. What we have discussed is similar to interoperability and open BIM. It's like we are sharing the data to other person without causing any damages to other at the same format. And it's like the ability of how much it can be shared to other softwares. Okay, if I am saying one file is I can share to any other software and can be used without any harm, it's 100% interoperable. Okay, that's what it says. Then data exchange platform is like the platform we are used to share the data. Those are one of examples. BIM 360. BIM 360 is the main example of Autodesk Construction Cloud, ACC. You just after the webinar, you may just search the Google like ACC, or you may just note it down. ACC is like Autodesk Construction Cloud. There's a different platform under the ACC itself. Those are paid but can be used by the client. It's very helpful in sharing the information. So next is facility management. Okay, guys, these are the two topics I didn't add in the slide. It's a very large topic. So I just briefly explain about that. Facility management, I think I have just briefly explained about them in the beginning. It's like as the word itself says, it's a management of the facility. Facility is also said as a building. Okay, the building we have done or the project, the management of the whole building. Even after the construction, after the LOD 500 as built construction, we have to manage the building, right? Only construction is not the main thing. After construction is the main thing. After construction, we have to make sure the building stays for more than the design period. The design period of a normal building will be 50 year or 100 year, but it has to stay in 100 year, right? In every construction, we see now the bridges are collapsing after like 1 month or 2 months, something is collapsing. So every building we construct has to stay for more than 100 year or 50 year. So those like maintenance and everything required to manage that facility is called the facility management. Okay. This is not only done in the BIM, but also for every construction we do. But for our BIM, like from the side of BIM, we would say every building we done using the BIM process. We have facility management, which contains every data we have added in the BIM model are also used for facility management, which means what to say, if you use a door, if you use a door with 2100 mm height, 1000 meter, sorry, 1000 mm width. Okay. And after the construction, it's about they're saying there is 100 years warranty the door has. So after 10 years, the door damages or the door, something happens to the door. Then who the contractor or every person related to the project dies. There is no information. But if we do the project by BIM, we have every information about that door in the software itself. We can access easily, similar to that BIM 360 you say, in the left side and right side, we can have the different different material we can access. So from that, if he access that door, he can get the information about from which company the door is made, from what material is used, what is the maintenance manual of this particular door, what is the warranty, and everything related to the door will be in that particular BIM model. So those data can be used in the facility management. Okay, I hope you understood. Like it's an example of a door only. Everything you can get from the BIM model for the facility management process. Okay. The next one is digital handover. So digital handover comes actually in between data exchange platform and facility management. It's like after data exchange platform, after completing the whole work, whole BIM related work, all the construction, everything work, we hand over the whole work to the client or whoever is the head. We hand over the work. That is called digital handover. Simple as it is. We just hand over the whole work to the client or any person or who is the main head, we hand over. So digitally we hand over. That's only the word says. Okay, guys, this is all about like little bit introduction. I hope everyone understood. There is a lot to explain about this one. Like dimensions of BIM is also left. It's also a very large topic. Yeah, I hope like we could discuss more in the upcoming slides. I'm sorry, upcoming webinar. Yeah, so I am just concluding. So thank you for your patience. Yeah, that's all about myself. And if you have any queries, you can contact me through WhatsApp, and this is a mail ID. You can share to me. Any job related or anything related to BIM, you can contact. I will guide you. Okay. Thank you.